you've been practicing wrong your entire life. And I don't mean that as an insult. I mean it literally. There's a mechanism inside your nervous system, something most coaches, teachers, and even neuroscientists rarely talk about, that determines exactly how fast you get good at anything. And the way most people practice actively works against it. I'm not talking about working harder. I'm not talking about motivation. I'm talking about a waxy white substance wrapped around the nerve fibers in your brain and body called the myelin sheath. And when I tell you what it actually does, and more importantly, how to make more of it, you're going to rethink every practice session, every rep, every hour you've ever put into learning something. So let's get into it. Here's a question most people never stop to ask. Why do some people improve 5 times faster than others doing the exact same amount of practice? Same hours, same instruction, completely different results. For decades, the default answer was talent. Some people just have it, some don't. Case closed. Except, the science completely dismantles that story. What researchers have found, and this took decades of neuroscience to untangle, is that the difference between a beginner and an elite performer isn't the size of their brain, or the number of neurons they have, or even their IQ. It's the thickness and completeness of a sheath wrapped around their neural circuits. And that sheath, you can build it, deliberately, with the right kind of practice. This is genuinely one of the most exciting things neuroscience has uncovered in the last 30 years, and most people are still out here grinding away, putting in hours that barely move the needle. Not because they're lazy, but because they simply don't know how this works. That's about to change. Think about the last time you actually got noticeably better at something. Not just familiar with it. Genuinely, measurably better. Maybe it was a musical instrument, a sport, a language, a work skill. And now think about how long that took. For most people, improvement in anything feels frustratingly slow. You practice, and there are these long, flat stretches where nothing seems to change. And then suddenly, one day, it clicks. You're faster, cleaner, more automatic. What just happened there? What actually changed in your brain during that flat stretch? Here's the thing most people assume. They think learning is about making new connections between neurons, building new links in the brain. And yes, that's part of it. But it's not the main event, not when it comes to skill development. The main event is something completely different. When you repeatedly perform a skill, the neurons involved in that skill fire together, over and over. And your brain notices. It sends out specialized cells called oligodendrocytes. And these cells do something remarkable. They wrap themselves around the axon, the long thin signal wire of the neuron, in tight spiral layers. Each wrap is a layer of myelin. And here's what that does. Before myelination, an electrical signal traveling down that neuron moves like a car driving on a dirt road in the rain. Slow, lossy, prone to disruption. After myelination, that same signal jumps from gap to gap at high speed, up to 100 times faster. The signal becomes stronger, more precise, and almost fatigue-proof. Think of it like this. Imagine the neural pathway for a skill as a garden hose. Every time you practice, you're running water through that hose. But myelin is like wrapping that hose in thick insulation. Suddenly, the water pressure goes through the roof, the delivery is reliable, and nothing leaks out along the way. The signal becomes what neuroscientists call high fidelity. And high-fidelity signals are what separate a beginner's clunky, effortful performance from an expert's smooth, automatic, seemingly effortless execution. Now here's where it gets fascinating. Myelin doesn't wrap randomly. It only builds around circuits that fire repeatedly, in the right sequence, with enough depth of focus to trigger the myelination response. This is why half-hearted repetition basically does nothing. And it's why the quality of your practice matters enormously more than the quantity. There's a researcher at NYU named Douglas Fields who spent years studying myelination and skill development. He found something counterintuitive. The sweet spot for building myelin isn't when you're performing a skill easily and comfortably. It's when you're right at the edge of your ability, making errors, correcting them, reaching slightly beyond what you can currently do cleanly. That zone of almost but not quite is where the oligodendrocytes kick into high gear and start laying down myelin at maximum speed. This is why elite athletes and musicians practice at tempos and difficulty levels that feel just slightly uncomfortable. It's not masochism, it's biology. Let's get specific with an example. There's a guitarist. Let's call her Amara. She's been playing for 3 years. She practices for an hour every evening, but she mostly runs through songs she already knows well. It feels productive. She's playing a lot of guitar, but her progress has plateaued. She's comfortable, and comfort, it turns out, is the enemy of myelination. Now compare Amara to her bandmate, Rohan. He practices for 30 minutes, but he spends almost all of it on a single passage he keeps getting wrong. He slows it down. He isolates the hard part. He makes the mistake, stops, resets, tries again. It's frustrating and sometimes boring, but after 6 months, Rohan is noticeably better. His playing is cleaner, faster, and more automatic than Amara's, despite putting in half the time. The difference? Rohan is myelinating. Amara is reinforcing existing circuits without building new ones. There's also a timing element here that most people completely miss. Myelin is built during rest and sleep, not during practice. Practice is the stimulus. Sleep is when the oligodendrocytes actually do their work, wrapping layers around the circuits you activated during the day. This means that cramming, practicing for 5 hours the night before, is almost completely ineffective for skill development. You might remember information that way. You will not build the myelinated circuits that create lasting physical skill. Sleep researcher Matthew Walker's studies show that skill consolidation, the process where practice becomes hardwired ability, happens primarily during slow wave and REM sleep. If you skip the sleep, you skip the myelination. It's that stark. There's one more variable worth understanding: age. Myelin production peaks in early adulthood and gradually slows over time. This is one reason children learn languages and motor skills so quickly. Their brains are in a kind of myelination overdrive. But, and this is critical, myelination never stops entirely. Adults continue building myelin well into middle age and beyond. The rate is slower, but the mechanism is intact, which means it's never too late to use this process intentionally. It just requires more precise, focused effort. Now here's where this gets immediately useful.